After the time of Aristotle, and people were still trying to make sense out of what they saw in the heavens, one of the early astronomers who did the best job that he could and actually created a very good model of the heavens was an Egyptian astronomer named Claudius Ptolemy. The P is silent. So Claudius Ptolemy looked at all of the data from the heavens, and he created a geocentric or Earth-centered model. Centric means centered, geo means Earth. At that point in time, there were no telescopes, and we only knew about Venus, Mercury, Mars, and Jupiter, aside from the moon and the sun. So those planets, he had to figure out a description or a model that would work to explain how everything is set up. Now remember, it was believed at that time that the Earth was the unmoving center of the universe. The challenge with that is the fact that we do move and we do orbit the sun. And so Ptolemy tried to make sense out of it, but it got complicated really, really quickly. In his original model, the Earth is orbited by the moon, then Mercury, then Venus, the sun orbits beyond that, then Mars, Jupiter, and Saturn. And believe it or not, Ptolemy kind of made this make sense, but oh honey, it got so complicated. And here's how it got complicated. Now the picture on the last page that looks like this, you go, well, that's not that bad. I can make sense out of that. But Ptolemy's model, geocentric model, didn't look simple. It actually looked like this, because there is a thing that occurs called retrograde motion. And you can either pause this video and go back and see this or watch these out at the end. But this is actually the weird and crazy motion as actually observed in the heavens. Retrograde motion is defined as the apparent backwards motion of the planets that we observe from planet Earth. This is not this is not just something weird and crazy they imagined. This actually occurs. If you look at the orbit of any planet over time, it's going to look like it goes forward and forward and forward, slows down and stops, turns around, goes backwards, backwards, turns around and stops, and then goes forward again. Well, first off, planets do not stop, turn around, and go backwards. They have so much mass and inertia, that's not going to happen. But it was observed. So they had to come up with a model that explained that. What Ptolemy decided would work is that as a planet orbits the sun, once in a while, just because, it would stop and do a little side circle, a little wacky side circle on the side of the orbit. The side circles on the edge of the orbits are called epicycles. They're little circles added to orbits to explain this backwards motion. Well, the challenge was, in Ptolemy's model, they very quickly ended up with over 300 epicycles. That's very, very complicated and confusing. What the heck? I mean, this is a very complicated method of explaining where the planets are. And so why does it look like the planets are moving backwards? It actually looks like the planets are moving backwards because one planet, as we actually do orbit the sun, is passing another one on the curve. So let me see if I can explain this. And I have a couple videos later that will do a more thorough job. But let's say this is Earth and this is Mars. And if we observe Mars on one day, we're going to see it here. Now, if we are actually traveling faster than Mars. So if here's Earth at number 2 position, here's Mars at number 2 position, it's going to look to us as if Mars is sort of slowing down. At one point in time, because we're going faster than Mars, if we look back towards Mars, it's going to look like it's stopped relative to us. And if we go faster than Mars at some point in time, it's going to look like Mars has actually started to move backwards. Very weird and crazy stuff. It is a optical phenomenon based on the fact that you've got two bodies in motion. I've got a couple videos I'm going to ask you watch after we're done with this section, one showing a real retrograde motion, and the other one, somebody else explaining it besides me, because that sometimes helps. So here was Ptolemy's theory. Ptolemy's theory dominated for over 1400 years. It contained about 80 epicycles. I think in a previous slide I said about 300. That number, I apologize, I probably had the 300 wrong. The thing about Ptolemy's geocentric theory is that it actually works. It works very, very well for predicting the positions of astronomical bodies and planets and things like that. But it's very, very complicated. And around in the late 1400s, there was a Polish astronomer, and his name was Nicholas Copernicus. This is a picture of Nicholas Copernicus. And Nicholas Copernicus, his ancestry was Polish. He was the second son of a wealthy family. The first son inherited the money and the title, and the younger sons very often got sent off to the church so they'd become priests, not father babies, and would not mess up the line of succession for some sort of a royal house. And that's where Copernicus came in. He, as a young boy, was sent off to church schools, and eventually he worked for the Roman Catholic Church for his entire life as a banker. He was a financial planner, and he took care of the money for the Polish church. During his education, Copernicus was sent to Italy, the home of the Catholic Church, and there he studied many things. One of the many things he studied was astronomy. Now, astronomy had nothing to do with his job, but it became a hobby. And he would look at the stars and chart their motion night after night after night. Copernicus had a gut feeling about Ptolemy's model, and his gut feeling was this. He said, bottom line, Ptolemy's model is too complicated. All of these epicycles, all these wacky orbits where something goes along and then has a little dipsy-doodle side orbit, Copernicus said, that's just weird and complicated. There's got to be a better way. So what Copernicus did is he developed a heliocentric model. Helio means the sun, centric means center. And Copernicus created the model that you and I are used to today, with the sun at the center of the solar system, Mercury, Venus, the Earth, the moon orbiting us, Mars, Jupiter, and Saturn. And it explained so many things. It got rid of most of the crazy epicycles. And so Copernicus wrote a little book on the subject. It was probably too small to be called a book, and it was actually more of a pamphlet. And the book is called On the Revolutions of the Celestial Spheres. Now, Copernicus worked in Poland. This was an area that was dominated by the Catholic Church. And so he had one of his friends smuggled it into Protestant Northern Europe, where it was published. The book was then brought back to Copernicus, and it is reported that he saw a copy of this on his deathbed, which was probably okay for Copernicus, because Copernicus, everything I have ever read about him, he was a nice guy. He was a little nerdy, he was a little bookish, he was very quiet, and he was not someone who liked or enjoyed controversy. So his book, his little tiny book, ended up causing a major amount of controversy, but he didn't live to be in the middle of the storm. Now, the theory that Copernicus published, he still clung to this notion that God lives in the heavens, and so the motion must be perfect. And because of that, he had to include 30 epicycles. Copernicus's theory was not immediately accepted because of the fact that it wasn't that much better. Yeah, it was a little bit simpler, but not totally simpler. So it was a major step forward, but it didn't revolutionize things until other people like Kepler and Brahe got their fingers into it. One of the things I do want you to be aware of is the word revolution. Now, if I say the word revolution today, you might say, oh, the American Revolution of 1776. You might say, oh, the sexual revolution of the 1970s. Revolution means a major upheaval in how things are believed, an upheaval in thought. Well, prior to Copernicus, the word revolution meant one thing only, and that meant to go around in a circle and revolve. After Copernicus, that word now has two meanings. It still has the meaning to revolve, but it also, that's where it got that second meaning, the major upheaval in thought. And that is due to the fact that Copernicus took the entire solar system, turned it on its ear, and said, hey, ladies and gents, the Earth actually revolves around the sun. That will do for this section. We're going to come back next, and we're going to talk about the next great scientist.